Okay, now that we got the transistor in place, I installed the 4 screws for the input module. That basically will go like that. And then the 4 screws for the output module, that will basically go like that. And I also installed a screw for this thermistor connection so that we can have the bias corrected for when the transistor is like really hot. It produces a negative coefficient so that it backs down the bias a little. So that's installed, but before we can get into installing the boards, all of these screws need to be in place and securing it to the heatsink. However, we're going to need a smear of heatsink compound on the back side of the copper, and go lightly, don't like really go too wild with that stuff. Use like a credit card or something, or some sort of spatula, and make a very thin layer between the two. The heatsink compound I'm using is Dow Corning 340. It's the mainstay for most heatsink compounds. You can get some really special stuff, but you know, this stuff just works. Again, don't go too wild with it. What I plan on doing on the back side of this thing, I think, is I'm not really too sure. I think I'll just figure out some sort of spatula, and or maybe a credit card, an old credit card or something, and just kind of smear it on this surface fairly thin. If it's like mostly white and with a little bit of copper, that's probably okay. Anyway, we're going to experiment. I think the thinnest layer is probably the best in this case. So all the heatsink compound is really needed is to fill the voids where there's just air, and the aluminum isn't making really good contact with the copper. So then we're going to install the M6 socket head cap screws. These happen to be 10 millimeter, I believe. Those are going to get installed, and then we're going to take this torque wrench, and we're going to torque all of these down to about 7 Newton meters, which I think is somewhere around 60 or 65 inch-pounds. So we're just going to go through and torque them all down with the torque wrench, and then we'll pretty much be done with this whole assembly. We'll install the boards and solder the tabs onto the boards like so. That gets soldered to there. Obviously this will have to slide in and make a connection. This will slide in and make a connection. Then we'll put positive and negative leads, which are here. Here's our monster positive and our monster negative coming from our Huawei power supply. We'll also have to add 12 volt for the bias, an RF input line, and an RF output line. And then we'll be able to ready to do a quick bench test and adjust the bias pot. We want about 1 to 1.5 amps of quiescent current to be flowing. So we'll play with that bias pot until we get up to about 1 amp, 1.5 amp of idle current or quiescent current, however you want to call it. So we're going to do that on the bench once everything is wired up. And I'll probably use a Zygu G90 set for 3 watt input or 5 watt input as the initial drive, just to make sure that all this is working correctly. And we'll look at it on the scope. We'll look at it on a spectrum analyzer and make sure it looks the way it should. All right, see ya. Okay, so here are some photos from the actual construction of the LDMOS amplifier. Like I said, unfortunately, I lost a lot of video footage of the construction, but I did take pictures, and they are posted on my QRZ page. We are at my QRZ page right now. So we're looking at this one. This is the next step, which would have been the installation of the input board and the output board, and in the center here, of course, you see the LDMOS transistor. All of these connections were soldered in, and then we did a bench test. I don't know if you can see that very well, but you can see the LDMOS amplifier pallet here. There's a power supply that's just driving this small power meter, and also the fans, the DC fans that are sitting right here. You can see them a little bit better. I can zoom in just a little bit more. There we go. Alright, so DC fans here. There's a G90 over here that's used to excite the amplifier. We're probably putting in maybe anywhere between 3 and 5 watts of drive. There is no input attenuation yet. In the final amplifier build, there's 12 dB of input attenuation so that it can be driven direct by like a 100-watt amplifier. This is a Huawei 3 kilowatt DC supply. It takes 110 or 220 as input and can give you 60 amps of 50 volt DC power. It has been modified by programming it to put out 57 volts, which is what the transistor package preferred, anywhere between 55 and 60 actually. So that's here. This is a little switch box that I made just for this bench test. Turns on the 57 volt main supply, if you will, to the pallet, and then also there's a switch for the 12 volt bias. And then some various other equipment, and then off camera is the a spectrum analyzer and a power meter. But what I saw during testing was that about 3 or 4 watt input was giving me 780 watts of power, and then as I increased the input power, I was already getting close to 1300 watts output. So once I established that the pallet could put out 1300 watts, I shut everything down and basically disconnected the assembly, the whole test setup, because I didn't really want to mess, basically destroy the amplifier by fiddling with it too much. I wanted it in the enclosure where it had other kinds of protection. There was an LDMOS protection board that goes with this. All these parts are from not DX Injury, sorry. They're from dxworld-e.com, and I think I put the information up the top here. Yeah, dxworld-e.com is where I got all the boards for assembling this amplifier. So this next little project was the 12 dB attenuation board. This is a resistor network of 10 dB and another resistor network of 2 dB in series, so that we can get 12 dB total. This allows me to put the full 100 watts from the ICOM into the amplifier and not cause any problems. So this is my machining of the front panel. You have 7 spots here for LEDs, and I'll show you down below a switch, 7-position switch knob for each band of the low pass filter, the LPF. A power on and off button. There's a display that sits right here. Some warning indications for overcurrent, overpower, and then a reset button in case you incur some error, you can reset it. So this is the back of the front panel. This is the LCD display and the LDMOS protection board. Some more wiring of the back of the front panel, the rear side of the front panel. Here's a great overview of just the amplifier. Not the low pass filter board. It would sit on top and upside down, so that all the coils and capacitors are pointing inward or downward. I did that just as a space saving measure. This enclosure is only 5 inches high, 5 1/4, I think. So really had to pack a lot. These are the main terminals for the 57 volts coming in. This one down below that is the 12 volts coming in, and then a PTT also coming in. And then let's see, this is more of the installation of boards and making connections. You can see the fans over here on the right hand side. And some of the connections to the rear panel. And this is the 99% completed amplifier, showing the LCD display, the switch for low pass filter, an RX and TX LED on the far right hand side, and then antenna switch with antenna indicators. However, I hadn't had them installed, and so what you see is antenna 1 is when the button's in the up position, and antenna 2 is when the button's in the down position. And another picture of the full amplifier. And that's about it for the construction of the amp. Now I can show you some of the actual performance of the amplifier. Okay, here we are in the shack. Got the amplifier set up here. The power supply is down here below me. It's the Huawei 3 kilowatt DC supply. Looks like a long loaf of bread, small, thin. That's providing the 57 volts to the amplifier. We also have a separate 12 volt line going into the amplifier for the DC bias and to run some of the logic in the amplifier. But the band indications here, and as you can see, I put a little piece of tape over here. We're going to start on 20 meters. The tape is to reduce the brightness of the LED. It was starting to wash out the camera, so that's what we did. There's also another one down here on the receive. You can just see it's slightly glowing. Also a little too bright for the camera. So you can see when I key up, it goes receive, transmit, Um, I have a end-fed half-wave on antenna 1 and a dipole for 15 and 20 meters on antenna 2. So we're going to start with the end-fed half-wave. We're on 20 meters here. We're on 20 meters on our ICOM 7300, and we're just going to find any random POTA activators maybe, or whoever else might be on 20. Let's see if there's something out there. I'm going to have to come up with a configuration where I can still use my headset and you guys can hear too, because just doing it over the speaker, it's really hard for me sometimes to pick people out. I'm just doing it this way so that you guys can hear it as well. I think we missed our chance. We'll get him the next go around. Whiskey 6 Delta Kilowatt Whiskey. Whiskey 6 Delta Kilowatt Whiskey. Whiskey 6 Delta Kilowatt Whiskey. There's a lot of QSB on the 20 meter band right now. I think this guy is on the East Coast. Whiskey 6 Delta Kilowatt Whiskey. Whiskey 6 Delta Kilowatt Whiskey. QSL, you got Dan here, San Diego, California. You are 5-5. Merry Christmas. All right, so first positive contact. He was all the way in Maryland, I think. I'll have to review the tape and pull out his call sign again. So that's 20 meter. Let's try 15 meter and switch the dipole. So 15 meter, gonna move a little piece of tape. Again, the tape is just to kind of blot it out because it's a little too bright for the camera. Alright, 15 here. Let's drop to 15 on the ICOM 7300. We're at 21.336 now. We're just going to scan, see if there's anybody out there. Oh, and we now just switched to the dipole. Whiskey 6 Delta Kilowatt Whiskey. We had a camera problem. It stopped recording. We're still on 15 meter. We're going to try to make a contact real quick on 15 meter. and then we'll wrap up this segment. I'm on the 10-15 meter dipole still. Yep. Amp is set to 15 meter. We're currently at 21.317. Sounds like a POTA operator out there. This guy is 5'9". Yeah, this is a W6SFO, Whiskey 6 Sierra Foxtrot Oscar. He's at Park 6393. Yeah, QSL, you're a 5'7" in San Diego, 57. Yep, QSL, have yourself a good one. Alright, so that was a positive contact, POTA operator. According to my ham clock back there, it's Whiskey 6 Sierra Foxtrot Oscar and Park 6393. Is that right? Sorry, 6593. Yeah, so positive operation on 20 meter, positive operation on 15 meter. Later tonight I'll be playing around with 40 and 80 meter and see what happens. I don't have a 160 meter antenna. Kind of wish I did sometimes, but I've never really found 160 all that interesting. I don't know. Maybe it's because I haven't gone down there. So I need to explore that, maybe. But all in all, it seems to be working pretty good. Let's see. Yeah, I'm pretty happy with it. It's kind of like baby it for a little while. I haven't been pushing too much power. That last QSO right now on 15 meter, I think was about 500 watts, just shy of 500 watts. So all in all, pretty cool project. Got a few more little details to do on the amplifier, but I'm glad it's working. And I hope you had fun watching me put together this amp. Anyway, see you guys next time.